It's a pleasure to be here again today. I'd like to introduce Dr. Tim Boone, who's the Head of Research and Public History at the Science Museum Group and Principal Investigator for Congruence Engine. He's an historian and curator of the public culture of science. He's published research, films of facts, material culture and electronic sound, and artefacts, understanding use, which relates to science in museums, documentary and music. He contributed to the museum displays, Making the Modern World, and Dynamics to Electronica. Research grants before Congruence Engine included AHRC-funded projects on the public history of science and technology, on sound and music and modernity, and an intermediate comparison of TV and museum representations of science. He's also a former president of the British Society for the History of Science. Dr. Tim Boone.
Thanks very much. And I should start with thanks. Heartfelt thanks to AHRC for funding the last 3 years of the Congruence Engine project. It's been a wonderful trip. Thank you for the team, Tertia and everybody who's organised this wonderful conference. Thank you to the project partners in Congruence Engine who very generously donated their data and time to our experiments. But especially, I'd like to say thank you to the wonderful team, the wonderful Congruence Engine team, who've done such interesting and powerful work. In this talk, I can only gesture to the enormous diversity of what the Congruence Engine team has achieved over the last 3 years. Instead, I will present a through argument about the project by unpacking the terms of my outline, which you can see on the screen. Other aspects, including our action research methodology, will be fully explored in our outputs, and a large part of the team is here and happy to talk about what we've done. And there's another session of demonstrations downstairs at lunchtime, and you can really see some of the nitty-gritty there. So I'll read that outline. We want to make all UK heritage collections fully accessible together to those who would use them. The means to achieve this are their digital records, but because of the history of heritage organisations, our current records are ill-suited for this purpose. In the main, they are thin, inconsistent, and isolate collections items from the context in which they make sense. In Congruence Engine, we have therefore experimentally created ways to link collections and with historical data, techniques that in various ways overcome the intrinsic weaknesses. Because the creation of a useful linked collection requires the agency of its potential users, and because computing techniques are fallible, the UK digital collection requires a social machine for the task, a human technical approach that mobilises human motivation and thereby overcomes machine incapacities. Many of our techniques employ machine learning, with the result that we have within our grasp the capacity to overcome decades of limited investment in collection documentation. But because we are using these techniques, we confront a series of ethical issues that demand to be researched, even as we press for the resources to create large-scale demonstrators and user interfaces to reveal the potential of what we have glimpsed. So I'm now going to unpack that 200 words for the rest of my time. To start, we want to make all UK heritage collections fully accessible together to those who would use them. That is the fulfilment of the core terms of our funding. The project has proceeded on the basis that to do good historical and curatorial work, it would be insufficient simply to connect museums to museums or just archives to archives, for example. A UK digital collection worth having should work intermediately across repositories that hold objects, documents, pictures, records of historic places, and sound and moving image media relevant to any subject. In Congruence Engine, that subject is industrial history. But don't get hung up on our industrial history focus. What we have done will be relevant for any subject. Our ultimate target for Congruence Engine is that the techniques we have developed will be deployed to bring more people to the collections themselves, each visitor empowered to integrate collections into their historical pursuits. In Congruence Engine, we are a little concerned that the term UK Digital Collection, that has replaced the previous term National Collection, is also not quite right. It's important to us as heritage sector people that the collection-centred digital resource for history that we are proposing is not an alternative to contact with the material, the real objects, places, pictures and documents. Rather, we are creating an invitation and a means to experience that materiality directly, to encourage visits to heritage collections, to the stores and the archives, even as we promote the new kinds of digitally enabled histories and curatorial practice that will use them. From the bid onwards, we have been clear that the core direct audience for the project is people interested in industrial history, in whatever way. We have been mainly concerned with amateur and professional historians and curators or archivists, but potential users of collections often do not know of the existence of collections relevant to their interests, or else they know they exist but cannot gain access to them. Further down the line, the improvements we propose will benefit wider groups of people, such as casual visitors to museums. Congruence Engine's End of Project Digital exhibit models this by addressing the visiting audience at the Science and Media Museum in Bradford. You can see a screenshot of that exhibit in development. That show will open, we plan, in January. Here again, we imagine that active amateur historians will be particularly interested in the exhibit, but we are also addressing people from West Yorkshire who will be attracted to explore the linked histories of where they live, as well as anyone excited to see how digital work can reveal collections and history. And now we turn to means. Only catalogue records have the potential to make collections available to these users, because virtually every heritage organisation has too large a collection to display everything. So much is in store. Heritage organisations have records of items in their collections for two reasons: for audit and for access and interpretation. As for audit, they need to know what they have, what its legal status is, and where it can be found. At the Science Museum, over decades, collections were audited using record cards that carried minimal identifying information. You can see one on the left, good enough to distinguish one item from another, but little more. A century ago, the museum separately held records for interpretive purposes. Curators wrote definitive display labels for objects, and in the majority of cases, they were gathered together in catalogues, like the one you can see on the right. But when it computerised its catalogue, the Science Museum used its audit records, not its catalogues. And this is the original reason for the thin data that represent our objects online. Moving cataloguing information up the scale to full enhanced record status is an aim we seek to address. But the funding to support this has always been difficult to find, because museums and galleries properly favour expenditure on the displays seen by millions of visitors over the backroom work of cataloguing. And it's worth stating that this problem is often much worse for the small museums that have significantly less money than the nationals. In these cases, they may only hold audit-level records, and their databases may only be for internal collections management purposes. So I say, in the main, the records are thin, inconsistent, and isolate collections items from the context in which they make sense. Let me just run through those quickly. They are thin, by which I mean that their brevity often means that the descriptions lack significant details, such as purposes, associated names, places, or accurate dates. Objects may be inconsistently recorded within a collection, perhaps because the curator lacks time to bring old records up to quality with those for new acquisitions. But the greater inconsistency is between different kinds of collections. Museums are different from archives and use different data standards. As we know, libraries gained a huge amount by the adoption of the MARC standard, itself the product of the application of computers, from 1965 onwards. The Spectrum standard for museum documentation has been less universally successful. And because of heritage organisations' differing historical purposes, what has mattered to each of them, and therefore what is encoded in their data, has differed from organisation to organisation. Third, from the interpretive point of view, the major weaknesses of data representing heritage items is that it isolates collections from the context in which they make sense. In museums, data represents single items rather than the collections in which they make relational sense to their curators. A loom in a textile machinery collection, for example. But more than that, the very act of collecting removes an item from its social historical ecology and puts it to work otherwise. Our loom, for example, ceases to be the working tool of individual weavers and becomes the representative of a stage in the historical development of weaving equipment. In summary of what I've said, the records we work with make it difficult for researchers to see these collections and to use these items within their normal work. This is especially true of object and media collections. The styles of digital historical work that use data most successfully are those where data has been made palatable to users. We come back to some themes from yesterday here. An example would be family historians' use of census data via Ancestry or Find My Past. These commercial services first digitally reproduced analogue access to demographic data sources and then template the practices around genealogy in a way that has simply not happened with most other kinds of mass data. Trade directories, for example, may have been digitised, but they have not been datafied. And in neither case, the census or the directories is the data yet widely or freely available in a form that makes it fully interoperable. So, as I say, in Congruence Engine, our answer is linkage of data. Most investigations in Congruence Engine then have been experiments as if we lived in a world of linkable open data. We have converted collections data sets from our partners so that they can become linkable open data, and we have created data sets that enable collections of objects to speak to each other. I'm referring here to what we have called connective tissue data. Let me explain. It became clear to us that to make collections of all kinds linkable to each other required the ontological leap of counting the data within collections as part of the UK National Collection, whether that data is currently analogue or digital. Trade directories were one of the inciting categories. Because they list individuals' addresses, trades and businesses, they hold the data that can potentially associate people, work, machines, products, places, and the rest. Historical individuals designated their occupations themselves for these directories, and this is especially powerful for linkage. To take the example from my colleague Aaron Rees's research. Susan Excel, a wool comber living in Saltaire from about 1900, can be expected to have used a noble comb, a particular kind of machine, locatable to a particular floor in Salt's Mill. An example is preserved in the Bradford Industrial Museum, and you can see it depicted in historical photographs. Now, to be able to make those links at an individual level would be satisfying for a family historian. But potentially this can be done at the level of huge data, a dense filigree of connection incorporating millions of people and heritage collection items that could enable a subtle and detailed social history of people, work and machines. In the second year of the project, as we sought to make it more intrinsically digital, we increasingly replaced our initial language of assemblage and association of heritage collections more explicitly of one of linked open data. Our aim at this stage was to go beyond the scale of normal case study-based historical work like the Suzanne Excel example to enable finely textured research at the level of factory workforces, towns or regions. This required a return to the approach of our previous project under the TANK funding, Heritage Connector, in that we were once again gathering data sets, extracting terms and using graph databases. Digital linkage of items across collections and with historical data would enable individual items to be reunited with their constituting contexts, returning the orphan object back to the family of its historical origins. And so, most of the project investigations explored differing ways of achieving linkage. Some of these are live in that they exist in the wild, in online data, and in museum collections management systems. An example here is the Wikidata taxonomy for textile machinery we have created. Others have been achieved by the combination of datasets lent by our project partners. In another investigation, starting with various unstructured sources relevant to industrial Bradford, we have been working to develop methods to extract graphs of entities such as people, machines, trades and places and their relationships. We have been bringing these together in an expanding knowledge graph implemented in a Neo4j graph database. The idea is that this could serve as a sandpit for human validation, regularization, and then further linkage using additional data science methods. The aim is to produce an experimental ARCHIS data management system to model what a local federated infrastructure might look like in practice. And we're doing this in a way that is compatible with the use of this software by our partner, Historic England. And now, finally, we come to the social machine. As I said in my outline, because the creation of a useful linked collection requires the agency of its potential users, and because computing techniques are fallible, the creation of a UK digital collection requires a social machine for the task, a human technical approach that mobilises human motivation and thereby overcomes machine incapacities. Congruence Engine was, from the beginning, designed to be responsive to what potential users of a linked data resource would want to do with it. As I have said, we want our investigations to make available collections resources and digital techniques to historians and curators to enable and enrich the kinds of history they are able to do. In part, this is to create a more responsive, more democratic model of access to collections, driven from the periphery of need rather than from the centre of provision. The national collection is so numerous as to be infinitely deep and wide, given that most archives are only enumerated and digitised to the part level, not yet to the piece, let alone to the level of datifying each piece. Our expectation is that linkage will occur where people want to do it. It is impossible that every data point could be linked, but where a need is felt, then it can be linked. And I think it's our task to enable this. I say that the motivation is democratic, but the other is practical. Most of the work needed for the creation of interoperable heritage data is human labour. I will put on one side for the moment the troubling use of tech companies' use of cheap labour from the south to build their large language models. There remains a benign aspect of human labour closer to home. The simpler digital tools, such as regular expressions and open refine, can speed the regularization of messy data, but their work must be intimately directed by humans. And then the more computing-intensive work, such as topic modelling or prompt engineering for interaction with large language models, is necessarily human work, drawing on expert knowledge, or even simply on the human common sense, not reproducible by artificial intelligence programs. These programs are only tools, as useless without human interaction as a screwdriver without a hand. So-called generative AI hallucinations, and we have seen plenty of those, are not incidental wrinkles about to be ironed out by clever programming. They are intrinsic products of the faux intelligence of these machines. Humans in the loop are required to remove them, just as pre-Ford, mechanics had to file down machine parts so that they would work together. Altogether, that is why we say that a social machine is required for the creation of a UK digital collection. We need the speed of automation, but we need the person's occupancy of the human world to ensure its results make sense and are of value in that human world. Let us say a little bit more about machine learning techniques. I speak of overcoming decades of limited investment in collection documentation. I do need to state that, although at one level what we are proposing is a catch-up in documentation, in other ways the linked data solutions that we are proposing present an entirely new opportunity for realising the cultural capital of collections. Many of our techniques employ machine learning. So, in addition to simpler computational techniques like regular expressions or OpenRefine, we have also used large language model technologies, as you can see on the screen. With ChatGPT being released at the end of our first year, we were able, because of the Project Action research methodology, to explore this flexibility, to explore many possibilities that have arisen in the generative AI gold rush of the last 2 years. I'm sorry, I don't have time to go through this technical detail or I'll overrun very badly, but you can see some of these demonstrated downstairs at lunchtime. On the side of text composition, the real power of text generative AI techniques is not at all in the automatic writing of closely argued historical scholarship, but in the vast speed-up in the creation of more functional prose. Investigations under the Congruence Engine umbrella have shown, for example, that given a set of different commissioned researchers' notes on previously uncatalogued files, GPT can produce serviceable formatted catalogue descriptions. Or again, film catalogue descriptions have been created from speech-to-text transcriptions of documentary film commentaries. If we are to standardize such digital pipelines, automation promises to enable more extensive cataloging of collections and therefore findability of collections items. I would like to stress, in talking about the application of this technique, that the project has employed both data scientists and humanities researchers, and that their rather brilliant work has shown the potential for the creation of hybrid individuals who have both curatorial and humanities instincts, but also a lived sense of what it means to work with data. And I think this is a very important innovation that's become much clearer over the 3 years of the Discovery projects. But because we are using these techniques, we confront a series of ethical issues. As I say, many of the project's successes after November 22, after the release of readily usable generative AI programs, relied on these techniques. In the experimental space of a research project, we felt an imperative to explore the affordances of these large language model-based techniques. Our experience shows that we confront several kinds of moral hazard in this work, which together counsel caution. First, we recognise that the training up till now of large language models on internet materials most often will amount to a form of copyright theft. Second, we also know that selection of texts and images for this purpose has been indiscriminate, so that archaic terms and now offensive attitudes may well be reproduced in the outputs of these models. Third, we certainly know that the stochastic parrot techniques on which these technologies operate do not have the discernment of a human reader, and that close human supervision will continue to be a necessity. How can this be done in a non-exploitative way? Fourth, we recognise that the environmental cost of running AI algorithms is high in terms of water consumption and especially of energy, to the extent that technology companies are buying up the future outputs from whole wind farms and are commissioning nuclear power stations. Fifth, many wise people are counselling that we are occupying just the latest in a series of AI bubbles associated with hype, both about the dangers and the capabilities of the current generation of technologies, both aimed to fuel what must be a time-limited gold rush. What happens in our applications when the bubble bursts? All this points to the need to develop a well-informed and critical ethics to guide the sector through the likely stormy next few years. With regard to the use of LLMs, it indicates the avoidance of trivial use and the championing of minimal computing solutions. The costs of machine learning solutions will need to be balanced with the costs and benefits of choosing lower tech, more labour-intensive, more human approaches. Implicated in all of this is a further area of ethical peril, that, as in blue-collar occupations in the past, automation runs the risk of creating technological unemployment in our sector. In the project, our ethos has been that these techniques could enable data creation effort, read cataloguing, that heritage organisations have rarely been able to afford. So on that side, all good. Ideally, mechanising this activity will eventually lead to displacement of curatorial work into more social roles related to using collections more creatively. But the record of historical precedent in relation to technological unemployment is mixed. As historians of science and technology in the project, we are conscious too that reporting now at such a point of flux, we are also witnesses to a kind of technological change that we would at other times be analysing historically, and that the technical possibilities that we are able to articulate now will soon become part of the historical evidence for our period. Coming to the end now. We can envisage a world of linked and open heritage data in which not only is it easy to find related items across collections, but where any collection item, object, picture, archive, document, film, historic building record, can be seen within a data neighbourhood, to use another of our project metaphors. That data neighbourhood is a virtual reconstruction of the social historical stratum from which it was removed at the point of acquisition. We can even imagine that world of linked open data as covering all subject matter and all collections. But such a world is a distant prospect. As Alex Butterworth put it in our project manifesto, he said, "Congruence Engine prototypes a framework for the creation of a national datascape of cultural heritage as an act of cathedral building, generational in its trajectory." Before we can reach up to that scale, we will need significant demonstrator projects to show what can be done when we move on from proof of concept to application. Such projects, diverse in subject, collections type and location, will be in need of new user-friendly tools. That is the second area of research and development that we need. Most of the techniques we have developed have required convoluted pipelines and hand coding using very new computing techniques that have been evolving fast. We need to equip the people in our social machine with apps and user interfaces so that everyday practitioners can readily create data from complex sources, clean the data sets, do the analysis, visualize the results, and archive the resulting data sets in a sustainable manner. We will need to work with the suppliers of collections management systems and with the commercial agents of data sets. We will need to develop a practical ethics for engaging with machine learning techniques. All that is required so that we will be able to actualize the potential of what we have glimpsed in Congruence Engine. Thank you.
Thank you so much, Tim. That was amazing. Do we have time for a couple of questions?
Hello, my question is, how do you see the museum data service recently launched by the Collections Trust kind of as part of this and feeding into it?
I think the MDS has come along at a fantastic time. Almost coinciding with the results of the Discovery projects and the end of Tank. I think the MDS as an open aggregator of data from museum collections will be essential for the museum side of the equation. And you'll have heard me say that I think this is about all types of heritage collections. And I'm sure that everybody involved with that doesn't want to make a museum silo there. And the National Library Data Service that Alan mentioned is obviously also part of that. I think it would be, we're not at the end of research and experimentation in this area. And I think that the people who are running the MDS are alive to the potential of working with the data that they're aggregating to be one of the places where the next stages of experimentation happens. And I think we'd all be excited to be involved with them in doing that work.
Do you have any more questions? Oh, just here, down the front. Oh, just here, lady in the grey jumper.
And I'm not. My question is, like, for every talk I've been to, accessibility is being used, but how do you view accessibility? Because it's a very wide subject. Who are you aiming accessibility at? What communities are you working with? Because it's a very wide subject.
Yes, it's huge, isn't it? And that was the ambition that we were set in the funding call, which was at that stage called Towards a National Collection. We now talk about a UK digital collection. Our model is to see what's needed to enable anybody who wants to do this sort of work to be able to do it. So accessibility is core to the Congruence Engine vision. I think it's probably more complicated than we thought when we started out, because I think it became quite clear fairly early in the project that we were making quite a difficult proposition to all potential users. One is that it would be valuable to join collections of different kinds together to enable different sorts of history. Well, who does that sort of work? Well, actually, museum curators do that sort of work when they make an exhibition. But I don't think that's not always the way that people work in, say, community history groups think. And I think the other aspect was, if you like, the unfamiliarity of digital techniques. So that in actual fact, lots of people, lots of community heritage groups are using digital tools all the time. I mean, they use Find My Past, they use Ancestry, they're doing digital things. When we went to the West Yorkshire Archives, there was a member of the Friends of the Undercliff Cemetery digitising the entire records of everybody who was buried there to make a web resource for their society. So I think people are used to working digitally in established ways, but so much of what we were exploring, especially with the machine learning work, was so novel. We need to go next stage to be able to demonstrate the potential of this way of working. And I think that in our project, that's only really been begun in the last year, and specifically in Bradford. But it's absolutely the aspiration to make anybody who wants to do this work, enable them to do it.